All right, everybody, let's talk about projects this week. Got an inadvertent project that popped up, an accidental one. So it happened last night. I have a very old water heater, and it went out on me a little while back, and it's happened. It's old, and you got a controller for the top element and a controller for the bottom element, and those controllers are meant to heat the water, right? So the elements go in, and the elements are pretty solid. It's not something you have to worry about usually. But the controllers on the outside, the electrical parts of it, went out on me. And I had it happen on both the top and the bottom. So not a big deal. You go get the parts, you replace the parts, and then a couple of years later, which was this year, from the last outage, it went out on me again. Okay. It causes the thing to pop. Now, the first time it went out, there was a little bit of melting around the bottom element. I thought, well, I don't know what caused that, but everything seems to be okay, and it's processing okay. Last night, it crackled a little bit and blew the breaker. All right. When I went to go take it apart, what had happened was, and this might be what happened previously as well, the tank has corroded, and that corrosion has caused it to leak. Now, like I said, you got an element at the top and an element at the bottom. That bottom element was the path for the water to get out because you've got these panels over it. This is kind of a design issue that the water was able to work its way around to the opening because that's where the controller is. And in that opening, it could drop down, and as soon as it dropped in there and dripped, it dripped into the electricals and shorted them out. Now you might think, well, that's kind of odd because you're talking about water usually needs to have some kind of conductor in it, right? Some kind of imperfection to it. Well, when you realize there's corrosion in there to begin with, you already have the imperfections. So it's not pure water that got in there. It was the water with the corrosions, etc., and it was enough to short it out. So the new project that I've got for that is I have a tankless water system I'm going to try out. Now, I am in Vermont, so you've got the temperature that you've got to think about. In addition to that, I have a well. Now, the well is down approximately 300 feet. So the temperature of the water down there should be fairly stable. Should be somewhere around 50 to 60 degrees. But as far as I know, when the pump turns off, it doesn't just drain the pipe. I could be wrong on that. I'm not 100% sure, but when it kicks on, I don't remember there being air in the pipe to the extent that it would cause anything. You would think that if there's air in the pipe, it would cause the tank to immediately fill with air and have to be vented immediately. I haven't had that happen, so there's got to be water in the pipe. So in the winter, that pipe is going to come up out of the ground. So at a certain point, I think it's about 4 or 5 feet, it's going to be subjected to colder temperatures than what it came up through. And from that height into the tank, you've got exposed pipe, basically. So that's going to be about, let's say, we'll round it up to about 40 feet. So 40 feet of pipe and water can be chilled by the outside temperatures or warmed by the outside temperatures. So in the summer, the water going to the tank should be a little bit warmer, and in the winter, it could be a little bit colder. And I don't think we're talking about a lot. I don't think the pipe has enough volume to it that would actually fill the tank, meaning that it's pulling water up out of the well for it. But I'm not sure of the volume of water that's in the pipe. But my tank's not not a tiny tank. It's a small tank. It's not a tiny one. So it's probably pulling water through. It's getting more water than what's in the pipe. So it should have it at a fairly constant temperature, maybe 10 degrees colder, right? So we'll say between 40 and 50 if it's 50 and 60 down below. But again, if I have to have a heater on the pipe to keep it from freezing in the winter, but at the same time, the heater's running all the time, so it should balance that out a little bit. But that water is going to come in, and if you're familiar with a tankless system, if anybody's seen a beer cooler, right? You get the keg, you tap the keg, and the keg goes into this thing that looks like a cooler that you put ice into. At the bottom of it is a plate system, and the beer goes through a labyrinth through that plating system, so it's getting colder and colder as it goes through. It's not a straight line from tap to keg. It's a serpentine, at the very least, route going through there. And because it's taking that path, it's hitting colder and colder areas. So the beer gets colder because it's segmented up. The same process works here in reverse for a tankless water heater, right? The water is going to come in and it's going to go through some channels. The whole thing's heated, but the more channels it goes through, the warmer it gets, so that it comes out the other end hot. The question is, will it be enough for truly hot water to come out of the back side during the winter? So that's what we'll have to find out. But the project here is going to be not installing that, because unfortunately I can't do that. I don't weld pipes, and the current tank that's in place has welded pipes, and I don't really want to play with that. We're going to have to pull the entire tank out, which is going to be difficult on its own. And because the way the shafts are, I think it's going to be hard to get apart, first of all. But I'm worried about the pipes getting damaged taking the tank out. So I'll have to have a plumber come in and take care of that. Plus, having an extra set of hands to help get the tank out of the way is going to be a plus as well. But the tankless system, unlike the tanked system, is not a floor standing unit. So I'm going to have to create a mounting setup for it so that when the tank's out, we can slide this mount in and hook the tankless system to the mount so that it's supported off the ground and run the cables to it. And this time when the pipes come in, I want to put something in there that's easier to get. If we can get away with it. I'm not sure what the specs are on the hot water side, but the flexible piping is something I would want to put in there if we can get it in, simply because it makes it so much easier to replace things on your own. If there was a flexible system in there right now, I wouldn't have this issue. I could undo the tank that's there, pull the flex off to the side, pull the tank out, and then I can mount this thing myself. It's 240 on the old one, it's 240 on the new one, so the wiring is simple as anything to pop in and take care of. It's just the stupid plumbing that I need to take care of. And again, having a place to mount it so that we can hold it off the ground. That said, the other projects that I've got going on this weekend probably is I think the weather's going to be nice enough for me to get out and get the actuators in place on the solar panels. I think I've got it so that I'll be able to drop it down into around 20 come winter and go up to the 60 in the summer. What I'm more concerned about right now is just getting it up to the 68, 69 degree angle from 0 being completely vertical and 90 being horizontal, getting it up into that range for now, because come winter, I can always put blocks in as to the lowest point it needs to be, which I believe is about 26, 27 degrees, and let the panels just sit on those, and I can take the actuators out if I need to, right? That'll let me take them in and winterize them, if you will. They wouldn't be out in the winter for the several months they'd be out in the snow. and then come, I think it stays in that range from about November through till February. In March, they've got to start moving again. So then we'll take them out in March and put them in place and get them ready for the rest of the year. So that might be a good way to do it. The other thing that it buys me is it allows me to take the actuators in and lubricate them, right? Get them re-oiled and anything else that needs to be done to them for repair, or get them set up for replacement so that come March I can go put them out. We'll see. The reason replacement might be a requirement here is the first set that I've got are absolutely rated for outside temperatures and weather conditions. The issue with those is they're short, right? So I could have set a double setup in place with one set that pushes the other set. I didn't want to go that route. It seems a little bit kludgy. But the other set that I've got, which is for the bigger panels, is set to bring them all the way up, but it's not made for necessarily being rained on. So I've got covers that I made for those. I need to put gaskets on the top of them, and these covers will take care of them through any rain. But again, that part of it's going to be underneath the panel, so the amount of rain they're going to get underneath the panels is pretty low, especially if they're taken in over the winter. But I think those are rated for 200 pounds each, and the throw on the shorter ones is 300 pounds each. The panels do not weigh anywhere near that. So I'd say the big panel that I've got with the 4 in there probably comes in somewhere around 150 pounds. So doubled that. And the shorter ones are going on a 2-panel setup. And the 2 panels, I swear, must weigh about 50 pounds tops, even with the metal that I put in there. So, 50 pounds for that. And they're rated for 600 pounds worth of push with the pair of them. Be mounting them on either side. And the actuators that I got, the first set, the outdoor created set, is the same type of actuators you'll see on those solar tracking systems. They can get a remote control unit, and all of them use the exact same remote control. They're all on the same frequency, which is awesome if you've got a setup like this, and maybe not so awesome if you don't. The advantage I'll have here is because it's connected to that, I can figure out if I want to put one controller and run both sets of wires into the one controller, or I can actually split that, right? I can put 2 controllers in there, one for each actuator. They can get their own separate power. They can get their, so they've got a single flow of power going out, but through 2 different units. Or I could just hold one back as a backup. Haven't decided which way I'm going to go with that yet, but it'll allow me with the controller to hit the button and let the thing just go up to the height that I want it to be, and I can put the digital level on it so that I can just hit the button and I can watch that digital level, because I don't have to be behind them to push them, right? The problem I've got right now is I'm either behind it or in front of it pushing it and trying to see what the level's like on an edge that I can't really get to while I'm sliding the thing up and down. This will make it much easier to do that and to keep an eye on what's going on. They're both pinned at the top and the bottom, so removal is just pulling out the little cotter pins that hold the pin in place, sliding the pins out, and out they come. So they're easy to remove. I'm going to set the electrical system up as easy to put together as possible. I've got a box that'll be going out there, and it'll be getting a power system coming into it. So I could set it up with a coupler so that all I have to do is I can pull the box too and the actuators out during the winter. The box will handle the winter. It's just the actuators. So I can set up a coupling system for the actuators as well and couple them inside the box itself so that those lines will go in through the glands. and the glands will tighten down around those, but there'll be a coupler inside that I can just plug it into, and then I can just disconnect that and pull those plugs out, and I'm on to the next. So we'll see where that goes on that project, and I'll actually have some video and pictures for that when I get that finished. I said hopefully it's going to be warm enough to handle this weekend. In addition to that, I have eco-friendly lawnmowers, let's put them. The one lawnmower I have is not motorized, so it's me that's the impetus behind it, which is great when your grass isn't too high. We've had a lot of rain, and the stuff's starting to get higher, so I have an electric lawnmower. Again, not something you want to use out when it's raining, and unfortunately, it's not a mulching one. And if you're not familiar with the difference between mulching and non-mulching, a mulching lawnmower is sealed so that the grass gets cut up and cut up and cut up inside of it and it's left where it falls, whereas a non-mulching one has the bag in the back, and this one doesn't have a very large receptacle in the back, so it fills up pretty quickly. But I run that off the power I get from my solar, so the electric lawnmower doesn't cost me anything to run because the power it's getting is from the solar energy that I'm getting. And that's enough to top the thing off and keep it running. So while it's great that I'm not using any gasoline, which I don't want to use in the first place, and it's basically free because of the electricity I'm getting, the downside is that my two mowers have restrictions to them. One is that it's got to be kind of dry outside. I don't want to be out in the rain with an electric lawnmower. But the other thing is the push mower, while it will kind of work in the rain, is a bear to clean up when that happens to it. But the other thing with the push mower is it's got to be pretty much a mowed area. It can't be too high. It does pretty good with a good height, right? So let's say you're keeping your grass at a ½ inch or an inch high, and you're going to 2 inches or 3 inches. It's probably fine for that. It'll go through it okay. But you get up to 4 inches, you get up to 4 times or 5 times the height of what you want to keep it mowed at. It makes it more difficult to go through. And again, in my yard, if you start getting up to those heights, now you're not talking about just grass that's in the way. Now you've got some other plants in there, and those are tougher to cut through. And they grow a lot faster. So if your grass is at 4 times the height, these plants are probably at 6 times the height. So, or 7. So it makes it a little difficult to go through. But those are the projects that are coming up. I'll have more updates on them. The structure, I think, for the tankless water heater, I got to check out what the weight requirements are. I could hook it to the wall. I don't want to hook it to the wall because the part of the house it's in, the immediate external wall to it is trailer wall. And I'm not sure what that's really like on the other side. And the other side of it is closet wall. And that's probably what it's going to be mounted to, is the quote unquote closet wall. But the closet wall was just, I think it's 1x1 or maybe 2x2, 2x2. And the 2x2 was framed, and it's more anchored to the ceiling than it is to the floor. So it doesn't necessarily go all the way down. I could just reframe that. So I might do that. I got to see which is going to be the best way to do it. Or I might build a complete frame that goes down to the ground and sticks out so that it's got a base to it. And then I can cabinet it a little bit down the bottom and use that bottom part for storage, for example. So I got to see where I'm going with that. And it's a tankless system, but I don't know if it has to drain. So I got to look and see if there's any kind of drain to it, because there's a drain spot that the tanked water heater has to have, obviously. And that's still there with a hose that goes outside. And I might reuse that hole. Or it'll give me the opportunity to finally close that thing up. So we just got to see. I've got the unit here. It's boxed, so I've got to go through the instructions and see how it actually sets up. I have more than enough. The electrician who set it up for the for this unit did a great job for the water heater. I've got probably an extra 4 feet of electrical cable. So even if we had to cut the thing off of the electric tank because we couldn't get in to get it out, we can just take it off the electric tank, cut it there, and just set it up for the other tank. I've got plenty of leftover cable for it. And I can adjust the height that I put the tank to. Now, part of that might be I'll need to ask a plumber how far down from the plumbing it can be. Because when you're talking about a hot water tank, your pipes come over and go down, both the cold and the hot. So they're from a height above the water tank. If this has to be on a par with that, then I got to make sure that my framing goes up high enough. And I'll probably just make the framing go floor to ceiling anyway, just to be on the safe side and tie it into what parts of the building I can at that spot. And again, put a frame on it so that there's more to it than just what's there. So it's got some extra supports to it. But we'll have to see how that's all going to go and how it all fleshes out. But those are the projects for this year. I will talk to you guys next week.